design intent. In this lesson we will take a look at design intent and how to incorporate it into our models. To do this, we're going to model a simple picture frame. Firstly, I will take you through modeling the picture frame with the incorrect design intent. And then secondly, I will correct my previous errors and remodel the picture frame with correct design intent. Okay, so to start, we'll open a new part document from our part templates created earlier. So to start off modeling this picture frame, I'm going to open a sketch on the front plane, and I'm just going to draw the outline of the picture frame using corner rectangle. I'm going to dimension this picture frame 100mm square. So this is the outline of our picture frame. So from here I'm going to extrude this a distance of 10mm. So here we have our outline. But now I want to cut out the inside of our picture frame, and to do this I will open a sketch on the object's front surface and look normal too. Again, I'm going to use the corner rectangle feature, sketch feature, and set it at any distance, and using smart dimension I set it to the right parameters. In this sketch I want a 20mm border the whole way around our picture frame. So I'll quickly dimension these. Okay, so now our sketch is fully defined and we have a 20mm border all the way around. So in our features tab we can extrude cut our picture frame now. So now we can see that our cut is going a distance of 10mm, and we know that our original extrude was 10mm, so this should take us the whole way through our piece. And it does. So there our picture frame seems to look correct. So let's check if it is. So we're going to right click on annotations and show feature dimensions. Here we can see every dimension of our feature. So our distance of 100mm. So as stated earlier, design intent is how our model will react to changes made to it. So we're going to change this dimension here from 100 to 150mm, and we'll see how our model will react. So we'll rebuild, and straight away we can see we have a problem. This is not how we want our picture frame to react. We want our picture frame to have a constant 20mm border, but here you can see we have an immediate problem. So by changing this to 150mm, this dimension here of 80 from the lower edge of a picture frame to the upper edge of the cut remains at 80mm. So in order to get our 20mm border back, we're going to have to adjust this 80 to 130 and rebuild. So now we have our 20mm border back, but still we had to change that dimension ourselves. So what if we want to revert back to our 100mm and rebuild? Now we can see we have another problem. Our 130 still has not adjusted, so we are left with a U shape rather than a picture frame. So we're going to have to change that back to 80 to get our 20mm border back. And there we have it again. So there we can see on the front plane alone we've caused problems here. So what about if we want to change our thickness? Rather than 10mm, what if we want our thickness to be 20mm? And rebuild, and here we have another problem. our cut has not gone the whole way through our picture frame. So to make this cut go the whole way through, we're going to have to edit the feature, or this feature dimension in here, which you can see is 10 millimeters, which is the depth of cut, or the end condition. So I'll just have a look at the end condition here. So we right click on a cut extrude and edit feature. And here's our end condition, so blind and a distance of 10 millimeters. So to change this to go the whole way through, we have to change our distance or our end condition. So we look at the end conditions, and straight away we can see that a better option than blind would actually be true all. So if we select true all and click OK, we can see that it's gone through the whole object again. So no matter what distance we set our 20 millimeters to, if we change that, the thickness, if we change that to 50 and rebuild, it's still going all the way through. So there is an immediate improvement in our design intent. So that's messy, as we can see. So we'll have a go now at modelling it, and this time we'll try to incorporate design intent from the very beginning. Okay, so we'll open a new part and we'll try and model it this time a bit better. So open a sketch on the front plane and draw a rectangle. This time I'm going to use center rectangle and start from the origin. Okay, so any size. And I'm also going to sketch the cut as well in the initial sketch rather than having to add it later on. Okay, so now I'm going to set the dimensions of the outer frame to 100 millimeters, 100 millimeters squared, so 100 millimeters. But now we can see that the distance here is 100 millimeters, but our distance here isn't. So to adjust that, what I'm going to do is I'm going to select this line, hold Control, and select the top line, and add a relation. So we can add these relations here: horizontal, vertical, collinear, perpendicular, parallel, equal, or fix. The fix will define the sketch as well, but it's just going to fix it in its current position. So what I want to do is I want to make them equal length, so we can make equal. And now we can see that the outer sketch is fully defined. So now I want to dimension my 20 millimeter border, so I'll do so by smart dimension again, from outer edge to the outer edge of our border, and set that to 20 millimeters. And straight away, because I have drawn that center rectangle secondly, it has defined the whole sketch. So we're ready to extrude. So we can extrude, distance of 10 millimeters. And here we can see our completed picture frame. So that's a lot quicker, number one, and we have one feature. In our previous example we had two features and a lot more dimensions as well. So by adding a few relations in the sketch, you can cut down on dimensions and improve design intent. So we right click on annotations and show feature dimensions. So here we have 3 dimensions. We had a lot more than 3 in the last example. So we'll see how our picture frame will react when modified. So same changes, we'll make the same changes. We'll change this 100 millimeters to 150 and rebuild. So it's a lot more proportional now. We've kept our 20 millimeter border of our picture frame. So that's what we want. So what if we change the thickness of our piece from 10 millimeters? We change this to 40 and rebuild. And again, we still have our cut going through all because we incorporated it in our original sketch. So I'm just going to change that back to 10 very quickly, and this back to 100. Okay, so another way of improving design intent is by using equations. So to use an equation, or to insert an equation, we go to Tools in our main toolbar and Equations. Now here we can see our equations menu. So we have the option here to add an equation, so we'll add an equation now. So this is where we'll input our equation. So to input the dimensions currently on our feature, we click on the dimension. So we click on our overall 100 millimeters. So the aim of the equation I'm about to input is I want the thickness of our border, which is currently 20 millimeters, I want that to be 1/5 of the size of our overall picture frame, so the outermost size of our picture frame. So to do that, we have our D1, sketch 1, which is our 100mm, is equal to, and we click on the 20mm, D2 of sketch 1 multiplied by 5, and click OK, and OK again. So here we have our equation symbol has come up beside our dimension. That means that this is driven by an equation, so if I adjust one, the other should adjust as well. So I'll adjust the 20mm, I'll change that to 30mm and rebuild. And here you can see that the outermost dimension of our picture frame has adjusted also. It's gone to 150mm, which is 5 times 30. So that is adjusted the way we want it to adjust. So that's showing good design intent. So keep that in mind when you're modelling your own objects in SolidWorks. Try and incorporate design intent from the very beginning.